Hello. Hello, am I audible?
Yeah,
Okay, fine. So, um, shall we start our session now, or should I wait? Do you have any, like after 8, you have any session? Should I start?
yeah, please.
Okay,
Yes, ma'am.
okay then. Okay, we will start with week 7. Okay. So in week 7, the first is we will be studying about random experiments, sample space, event, null events, subset, probability, axioms, and addition rule of probability. These are the topics that we are going to learn in week 7. Okay. So first of all, what do you mean by an experiment? Anyone? What is an experiment?
It is a trial and error process which we do to get some outcome.
Yeah, it is just yeah, we can say that the process. Okay, it is a process that produces an outcome. Okay. Now, what is random experiment?
Ma'am, with the same thing, the outcome is not predictable. There is
Yeah,
uncertainty with it.
yeah, it is the same thing as an experiment, but in this we are not sure what will be the what will be the outcome, right? The outcome is not predictable with certainty. Okay. For example, if I'm tossing a coin, okay, so my sample space would be like head and tail. Sorry, my outcome would be head and tail, right? But we are not sure if when I'm tossing a coin, what what side of the coin will occur. If I will be having head or I will be having tail. So I'm not saying in certain way that I would be having a head or a tail. So that's why this is a random experiment. Fine.
50% chance.
Yeah, 50% chance. That's the thing. We are having 50% chance that it would be a head or a tail, right? We are not, but for not sure like what would be there in the outcome, right? 100% sure, right? Okay. Then we have the sample space. What is a sample space?
Ma'am, it's collection of all possible outcomes of a random experiment.
Yeah, correct. This is the collection of all the outcomes. Okay. So for example, if I'm having if I'm tossing a coin, so what would be the my sample space?
Head and tail.
Head and tail. Okay. Similarly, if I'm if I'm rolling a die, what would be my sample space?
1, 2, 3, 4, 5, 6.
Yeah, that's the sample space. Okay. Till now, this is clear. What is random experiment and sample space?
Yes,
Yes,
ma'am.
ma'am.
Okay, then. Now comes the event. What do you mean by events? Okay.
Occurrence of any event, occurrence of any.
You can say a subset of the sample
Subset of
space,
sample space.
right? Like if I say that I'm tossing a coin, my sample space is head and tail. So I'm considering A as an event, which is the occurrence of a head, right? So if you look at this, A is a subset of S, right?
Yes.
Correct?
Yes, ma'am. Yes,
Yeah.
Yes,
ma'am.
ma'am.
So like if I'm tossing coin twice, okay, my sample space would be head, 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 tail, tail, head, and tail, tail, right? So if I'm considering my A as an event in which in my first toss, there are head only, right? So that means head, head, and head, tail. These are the outcomes.
Yes, ma'am.
Yeah. So this is
Yes,
an
ma'am.
event, which is a subset of a sample space. Fine. Fine by everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Now comes the union of events. What do you mean by union?
Combination,
Combination?
like
Like,
all events.
yeah, if I'm having two events, E and like F, then union of events is denoted as E union F, right? This means that like either you can say E or F. You can say that. Okay,
Yes, ma'am.
fine. Okay. Then like for example, if I consider like okay, this is the same thing. Okay, A is an event this and B is like event TT. Fine. So my A union B would be
HH,
HH,
HT,
HT,
TT.
TT.
correct. Okay. Everybody is clear with the term the union of events?
Yes.
Yes, ma'am.
Okay. Then comes the intersection. What is intersection?
The set of commonly present things
Yeah, it
between.
is represented by E intersection F, which is like E intersection F can be considered as both E and F occurs. Okay, so just remember, if in the sentence it is coming or, then we use the union, and if it's having and, then we use the intersection symbol. Fine.
Yes, ma'am.
Okay,
Ma'am.
so if yeah, so so if I consider like A is an event in which HH and HT, okay, and B is an event which is having HH and TH. Okay, so what will be my A intersection be?
HH.
HH.
HH, right? That is the common between the two events. That's the intersection. Okay, now comes the null event. What do you mean by null event?
Empty.
Sorry,
Event
empty.
without any
Yeah,
elements.
Event without element.
yeah, with doesn't have any elements. So we denote it as phi. Okay, so in this only we have disjoint events only. So what do you mean by disjoint events?
No common elements.
No common
No
elements. That means,
intersection.
yeah, that means the intersection
Zero.
of, yeah, intersection of
Is a null
E and
set.
F is a null set. Okay, that means, and disjoint events are also called as
Mutually exclusive.
Mutually
mutually
exclusive events.
exclusive events. Correct. Correct. So, like for example, if I say that, mm, like in this example only, so so if this is these are both the events. So what is my A intersection B?
Null set.
Null set. Okay, that means they don't have any common events. Sorry, common points. Okay. Now we have complement of an event. What do you mean by complement of an event?
The events which are outside this event.
Yes, outside.
Which does not
The
belong to a
elements which present in
specific.
universal set, but not in A.
Not
So
present
like for
in the specific event.
yeah, so if I draw a Venn diagram like that, this is an event F. Okay, so my complement of F would be this is of my whole sample and this is my event F. So my complement FC, this is my we denote complement as FC, which will be equal to S minus F, right?
Yes.
Right? These are all the F complement is they are all the events in which the outcomes that are not in the sample space. Sorry,
No, that are not
the
in F.
outcomes in sample space that are not in F. Okay. Okay. Now tell me what will be the complement of a sample space?
Set.
Null.
Empty
Five.
set.
Empty set, which that is 5. Okay. Okay, now. What do you mean by subset?
Part of the set.
Part of a set. Yeah, or you can say that like there are two events, E and F. So if all the outcomes of E are also in F, that means E is a subset of E is a subset of F. Okay. Yeah. So for example, yeah. So for example, I'm tossing like two coins only. So if my E is like my E is an event as HH and F is an event as HH and HT. So is my E a subset of F?
Ma'am.
Yes, ma'am.
Yeah,
Yes, ma'am.
because the elements in E is also contained in F. Fine.
Ma'am, here
Yeah.
the sequence of the occurrence of the event does not matter. Is that right? In a subset?
Sequence? No, it doesn't matter.
As in, like, it's not necessary that first year you have to have an HH and only then you can have an HT. That is not necessary, right?
No. Okay then. Now, just a second. Okay. Now comes the probability. What do you mean by probability?
Chance of occurring
Chance
at
of
the top.
occurrence.
Chance of occurrence. So what is the formula? That is the number of favorable cases
By total.
by the total number of cases, right? That's the probability. And we use probability to predict something, right? So if I'm tossing a
Yeah.
coin, right? So what is the probability of getting a head? It is
Half. 1/2.
1/2, right? That means the probability of this is a favorable case and this is the total number of case, right? Now in this probability, we have axioms. Okay, we have 3 axioms. So the first axiom is, what is the first
And
axiom? The
probability
probability
will
of
be
any event should be between 0 and 1, right?
Yes, ma'am.
Right?
Should be equal to 1.
Sorry.
Sum of probabilities of occurrence of all events should be 1.
Yeah, that is probability of the S, or you can say the sample space is should be equal to 1. Then the third property states that probability of
E naught is
union
1
of,
minus E.
no, the probability of union of EI, that is EI is going from 1 to infinity, is equal to summation of probability of EI. So here we are considering that E is an event which is a mutually exclusive. Which is a mutually exclusive event. Okay. So if I'm having a mutually exclusive events, that is, or like disjoint events, then the union of all the events EI would be equal to the sum of the probabilities of EI. Okay.
Yes, ma'am.
Is it fine? All the three axioms?
Yes, ma'am.
So if you consider
Yeah,
that
ma'am.
I'm having two, like if I consider I'm having two events, which is E1 and E2, and they are disjoint, then probability of E1 union E2 would be equal to
Probability of E1 plus
E of E2.
Separate.
Probability of E1 plus probability of E2.
Ma'am, what is the use of this axiom?
This is just an example that you have to like make sure that the probability should be like if you're solving any probability questions or something and you are getting any probability, that should be between 0 and 1. It can't be greater than 1. And if you're having like a sample space and you're calculating the whole like just say that I'm having like I'm tossing a coin. So probability of S is 1 by 2 and probability of tail is 1 by 2. So the probability of my sample space, total sample space would be 1 only, right? That is 1 by 2 plus 1 by 2. That is 1 only,
Yes.
right? So these
Yes,
are
ma'am.
some of the conditions that you should remember in probability.
Okay, ma'am.
Okay. Yeah. So, and yeah. So when this is the condition in which my like if my events are mutually exclusive or disjoint, then union of EI, all the events would be equal to the summation of their individual probabilities, occurrence of that probabilities. Is it fine?
Yes, ma'am.
Now, somebody was asking something?
Just said yes, ma'am.
Okay. Then we have the addition rule of probability. What do you mean by that? See, this was the condition in which my sequence of like my events are disjoint. Now I'm having condition that they are not disjoint. Then my probability of E1 in union E2 would be equal to probability of E1 plus probability of E2 minus probability of
Intersection.
E1 intersection E2. Is it fine? Okay, just remember that when they are disjoint, then we can use this formula. Okay, but when they are not disjoint, we will use this formula. This is the addition rule.
Okay.
Fine? Okay.
Yes, ma'am.
Yes, ma'am.
Ma'am,
Okay.
this formula could essentially just be used for everything, right? I mean, in case of disjoint, we know that it is pi. Like there
Yeah,
is no
like
value
if
for
there are disjoint, yeah, same. You can like if you remember this formula only. So if this is disjoint, this would be 0 only,
right.
right? So I would be having this
The
formula
third
that
axiom
is
is derived from this one.
yeah, correct. Okay.
Yes, ma'am.
Yes, ma'am.
Okay, so let us do one example of this addition rule of probabilities. Okay, so for example, a student has a chance of 40%, okay, that is 40% chance of receiving A in statistics. Okay, this is one example. Okay, there is one student who is having a 40% chance receiving A in statistics, then 60% chance receiving A in mathematics, you can say. Okay, then it is given that 86% chance of receiving A in either statistics or mathematics. Fine. Now you have to find out the probability that the student receive A in both statistics and mathematics.
14%.
14%.
Okay.
8%.
So how you would, yeah. So let's do step by step. So let's just consider that probability. Yes, that is the probability of getting grade A in statistics is, what is the probability?
0.4.
0.4.
0.4. Probability of getting A grade in maths would be 0.6. And what is, yeah. So can you tell me what is this representing?
PA union B.
Yes, union M.
Intersection.
S union
M.
Ma'am, 6%. Either is stat or maths.
No. See, like whenever there is a sentence like either stats or maths, that means,
Sorry. Got it.
got it? So it would be probability of S union M, which is 0.86. Now I have to calculate A in both stats and maths. So I would be calculating probability that what I would
S
Intersection.
in S intersection M.
Intersection.
and S intersection M. Okay. So what I would be like, what would be the formula?
0.86 minus
Probability of
M
A
minus S.
Probability of
S
A
plus M
union
Yes,
S.
plus
plus
M minus
probability of M minus probability of
probability of S
S
union M.
union
It
M.
is name.
correct. Correct. So it would be 0.4 plus 0.6
6
minus
minus 0.86.
0.86, which would be equal to
0.14.
1.
0.14.
Is it fine?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yeah.
Correct? Okay. Now, if I have to, like in this
Ma'am, in
example,
place of either, if we got neither stats or maths, then how will we solve this?
neither stats or maths.
Or maths, yeah.
That means like I have to like it is same as probability that S union M complement. I have to calculate this thing. This is neither stats nor maths, right? It's just see, either stats or maths is S union M, correct? Now in place of
Yes.
either, it's just neither. So it would be the complement of this,
Yes, yes.
Yeah.
correct?
Yeah.
Yes, ma'am.
So
Yes,
it
So
would
ma'am.
be
1. So then it will be 1 minus 8.6.
1
Same result
minus
will come.
0.86.
The formula is actually 1 minus S intersection M, right, ma'am?
Sorry, what?
The formula for this is probability of S union M complement is 1 minus S intersection M, right, ma'am?
Why?
No, 1
It's
minus S union M.
union M.
Okay, ma'am.
Okay. Yeah. Is it
Excuse
clear?
me, ma'am.
Yeah.
Suppose like De Morgan's law, no? 1 minus something.
De Morgan's law.
1 minus P as union M. I've not understood because late joining.
See, what do you mean by complement of an event? Like if I have to, like there is one sample space, okay, and there is one event F. So what is F complement?
Oh, okay, F complement.
Yeah, what will be that?
1 minus
That's
which
the sample
S is
space
a event.
minus F.
Oh, so yes, S minus F. S is a sample space and F is events.
Yeah, correct?
Yes, yes.
Okay, is it fine?
But this is
Yes, is
only
it fine?
possible when P
Fine,
of
fine.
S union M complement and P of S union M is a mutually disjoint event, right?
S union M are mutually disjoint events.
Yes, yes. Like the formula is P of E complement is equals to 1 minus P of E. And this is only possible when P of E complement and E and E complement are mutually disjoint.
I'm not getting your point.
Ma'am, we cannot write this P of S union M complement until we know that this is mutually exclusive.
This is the question. They have like one student asked me, like if I have to calculate that they didn't had grade A in neither stats or maths. That's why we have calculated this thing.
Okay, ma'am. Okay.
Yeah.
Excuse me, ma'am.
Yes.
Can you depict this on the Venn diagram too?
On the Venn diagram.
Yes, ma'am. The following question.
Okay, let's see. So this is my sample space. So I'm having stats 1 and 1 maths. Okay. So probability of getting this is stats. Okay. And this is maths. So this is 0.4, right? And 60%. A in either stats or maths. That is union of that. See, this would be 0.4. That is the 40%. That is the probability of S. Correct? This would be the probability of M. Like here, this would be the probability of S intersection M.
Intersection M.
Correct?
Yes, ma'am.
So I have to calculate this middle part, right? This one.
Yes, ma'am.
So it would be probability of S plus probability of M minus the union of that, right? So if, like for example, see if so, this is probability of S, okay? Then this is the probability of M, and the whole S union M, this whole, you can say, okay, this whole, you can say is probability of S union M, right? So if I have to calculate this part only, I would be like summing these two and subtracting the whole part. So I would be getting this part only,
Yes, ma'am.
correct? So that's why we had this formula S intersection M.
And the complement will of the union will lie outside these, no, ma'am?
Yeah, outside this.
Got it. Thank you.
Okay.
Ma'am, quick question. These formulas are applicable only for independent events, correct?
Which formula?
These PS intersection M is equal to PS plus PM minus P.
No, these are not independent events. See, the independence and disjoint events are
These are
both
dependent
different
events.
things. If they are disjoint, like if they are not disjoint, then we have this formula. If they are disjoint, then we have the third axiom, right? This one.
Okay, so this one is for independent events.
See, independence and disjoint are different. These are disjoint events. Independency, we will talk about that later in week 8. So in week 7, we have disjoint, mutually exclusive,
Okay.
or we can say the disjoint events.
So these are exclusively used for disjoint or mutually
Disjoint.
exclusive events. Okay.
Correct.
Thank you.
Okay. Okay, fine. So like that, in week 7, these were the topics that was important. So anybody having any doubts in anything?
The S union E to the whole complement can also be written as S complement intersection M complement.
S complement, intersection, M complement.
Intersection M complement.
Yeah, you can write it like that.
And we'll get all questions in quiz from this concept.
Yeah, this concept. But you have to read the question carefully, okay? You need to see where we are using the intersection, where we are using the union part, okay? Fine?
We should see or and.
Okay, so, okay, let me take one more example, like same like that only. Okay, so if I have a customer, okay, and he purchases a shirt with probability, I'm having probability 0.4. So this is the purchase of shirt. Similarly, the customer will purchase a pant, okay, with probability as 0.3. Then he will purchase both shirt and a pant, okay, with probability 0.2. So what will be the probability that he purchases neither shirt
0.8.
nor a pant? Okay, so just tell me what are the values that we have been given. We have been given probability of S, which is 0.4,
0.5.
Probability of P
P, which is
0.3.
0.3.
And
Then
probability of S
Intersection 0.2.
intersection P
equal to
0.2.
0.2.
And we
Yeah.
have to find S union P complement.
Correct. So this is equal to 1 minus probability of S union P.
So it will be
Yes, ma'am.
0.5.
So this will be,
Yes.
now, first of all, we will calculate S union P first, right?
Yes, ma'am.
So this will be equal to probability of S.
Minus 0.2.
Plus probability of P minus probability of S intersection.
Correct. So this is 0.4 plus 0.3 minus 0.2, which will be equal to 0.5.
0.5.
5.
So probability of
So
S union
neither
P
shirt nor pant equal to 0.5.
is it 5?
Yes,
I
Yes,
think
ma'am.
everybody got the concept.
Yes, ma'am.
Yes, ma'am.
Okay. So like in week 7, you don't have any doubts for now?
Yes, ma'am. No, it's
Everything
clear,
Ma'am, I
ma'am.
have
Yes, ma'am.
doubt
No
in a
doubts.
week 7 practice assignment.
practice
Can
assignment.
I ask?
Yeah, which
Yeah.
question?
Ma'am, is this only the formula we
Ma'am,
used in week 7?
7.6 activity question in a question number
Okay.
2.
Okay. Find the probability of selecting a red card or a 5 from a deck of 52 cards. Okay. So it's the question for everyone. Okay. So we are having a deck of 52 cards. Okay. And we have to find out the probability. What is the question? Probability of selecting a red card or 5. Fine. So how will we calculate?
प्लेइंग कार्ड्स में क्वेश्चन करने के समय बहुत दिक्कत हो रहा था मुझे.
मैम क्या आप एक्सप्लेन कर सकती हैं 52 कार्ड्स में कौन कौन से कार्ड्स और कितने कितने होते हैं?
हाँ, आप
Okay.
अगर
Uh,
करेंगे तो बेहतर होगा.
हाँ.
यार हमें पता नहीं है.
Okay, okay. See, in
1
52
by
cards,
52 plus 4 by 52 minus 1 by 52.
okay, just a second, I like first let me tell what are the cards
Okay,
that are
ma'am.
present in 52 cards. Okay, so in 52 cards, they are like they are divided into 4, right? 13, 13, 13, and 13. Okay, and first 13 is like the spade of cards. Then next 13 are like you can say clover shape. Okay, and third is like diamond, and the fourth is heart shape. Okay, these are the shapes. Fine. Like it is a shape of a leaf, this is a shape of a flower, this is a shape of a diamond, and this is a shape of a heart. Is it fine? Okay, these both are of black colors, and these both are of red colors. Till now, is it fine?
Yes, ma'am.
Okay, and each of these cards, they have face cards. Okay, there are 3 face cards. What are the face cards? King,
King, Queen, and
Queen,
Jack.
and Jack. Similarly, for this, we have face cards. Okay, these are King, Queen, and Jack. And other than that, we have numbers,
Ace
which
2
is
to
2,
10.
yeah, Ace, 2, 3 till 10. Similarly, for this, Ace, 2, 3, and 10. Uh, like mostly we use 1 for Ace. Fine?
Yes, ma'am.
Okay, is it fine for everyone?
Yes,
Yes,
ma'am.
ma'am.
Is the class clear? Okay.
So,
Now the
so ma'am,
question,
26 red and 26 black card.
yeah,
In
we
which
have 26 black cards and 26 red cards.
and
The
inside
answer will be 28 by 52.
28 by 52,
Yes, ma'am. 7 by 13.
7 by 13.
How?
Okay,
What's
so,
approach?
okay, what will be the approach? Okay, let's see. So in total, we have 52 cards and we have to find out the probability that it is a red card or a 5. So that means we have to calculate probability of R. What we will be calculating?
Probability of R union 5.
Correct. Is this clear what we have to find? Who asked this question?
Ma'am, can you repeat? Here
Ma'am, what is
5, what
5
is
here,
5?
ma'am?
Okay,
Yes, ma'am.
let me represent R for the red card. Okay, and F for 5. Okay, so I have to calculate the probability that it is a red card or a 5. That means probability of R union F. There is an OR. That means you have to find out the union. Correct?
Yes, ma'am.
Now
Yes,
this
ma'am.
probability of R union F would be equal to
Probability of R plus probability of F minus probability of R intersection F.
correct. Okay. Now what is the probability of getting a red card?
26 by 52.
1 by 2.
1 by 2.
Correct. 1 by 2. What is the probability of getting a 5? 5.
4 by 52.
4 by 52. And what is the probability that of getting it is a it is a 5 and it is a red color?
2 by
2 by
52.
52.
2 by 52.
Ma'am, will
2
you
by
probability of comes?
sorry?
Will you explain the probability of
Your voice is
5, ma'am?
breaking.
How does it come?
Your voice is breaking.
Probability of
Ma'am, she is
How we
asking
update?
for probability of
Ma'am,
5. How does it come?
Okay, probability of 5.
yes.
Okay, see, like we have four types of cards, right? So in each of the four shapes of cards, we have 1, 2, 3, 4, till 10 we have numbers, right? In this we have 1 to 10, in this we have 1 to 10, in this we have 1 to 10, and in this we have 1 to 10 cards, numbered cards, right?
Yes.
Okay, so in this particular shape, we would be having one card which is of number 5. Similarly, for in this shape, we would be having one particular number which is 5. Similarly, for this and this. So in total, we have how many cards of 5 number?
4.
4.
4.
And how many
Okay,
total
ma'am, I
cards are there?
understand.
52. Got it?
Here 5, here 5 is a card's number.
Yeah, it is
This
the
is
card number.
confused me. Yeah,
Yeah, it is the card number. Okay. And you got it
understood.
when R intersection F, you got it?
Yes,
No,
ma'am.
ma'am.
Okay. So
Ma'am,
we
I
would be
have
solving. Yeah.
ma'am, sorry, I have a question on that R intersection 5. So
Okay.
usually I get confused with this. So see, our total number of cards which are red is essentially 26.
Hmm.
Correct? So would it be 2 by 26 or would it be 2 by 52? How to come to a conclusion on that? Ma'am.
See, we are, it's just that from the total cards we are selecting, uh, like from
So
the
we
total
have
cards we are selecting,
to,
please mute yourself.
and then we will have total 28 cards.
Shivam, can you mute yourself? Yeah. So R intersection F means that we have to select from the total cards, we have to select a card which is of red color and the number on that card should be 5. Right?
Okay, okay,
So yeah.
okay.
So in total, like we have two cards which are of red color, right? From that two cards, we would be having two 5 number cards.
That is correct. Yeah,
Yeah.
that is
So
correct. That I
that
understood.
yeah.
That if in case our sample space is entire, like if our sample space is to be considered the entire set of cards, then it will be 2 by 52.
Correct.
I was just wondering that. Okay, okay, ma'am, that's fine. Because I think once we have a probability of find the 5 given that the card is red, only then it will be 2 by 26. But this is a different. This is
Yeah, you would be
right.
like it would be mentioned in the question what would be the sample space.
Okay.
But
Okay, ma'am.
ma'am, we are choosing five cards from the four categories: spread, diamond, heart, and which this one? Hello,
Yeah, your what? Can you repeat?
ma'am. We are
Yes.
choosing 5 cards.
No, we are not choosing 5 cards. We are choosing cards with number 5 on it.
Number 5.
Yeah, we have a card like there is a card with number 5. We have a card with number 2, 3.
Yes, ma'am.
Yeah. Nobody has played cards.
Yes, ma'am, I have.
Yes,
Yeah,
ma'am,
is
I
it
No,
have.
okay?
ma'am.
I have, but can you open and
No, ma'am.
remind me again?
Sorry?
I got forget because long time ago.
Yeah, we like see there are four types of cards, right? Spade, clover, diamond, and heart. There are like 26 black cards, 26 red cards, if you
Yes,
remember.
ma'am.
Yeah, you can search it on Google if you want. Fine?
Yeah.
So
Okay.
in a general scenario, we will take the all outcome, whole sample space as the
Whole
denominator, right?
Yeah, as the denominator. Yes.
Okay.
Fine. But you should like read the question carefully, because in the activity that the person has asked me, it is the question is find the probability of selecting a red card or a 5 from a deck of 52 cards. So we are selecting from a deck of 52 cards. So it has been mentioned that the sample space is 52 cards.
Okay.
Got it? So
Yeah.
you like just read the question. You would be like you would get to know which is the sample space that you have to consider. Okay?
Okay.
Yes, ma'am.
Yes, ma'am.
Ma'am, I have a doubt in one practice question. Can I ask?
One practice.
Week 7.
Which one?
First one, ma'am. In a horse race, 6 horses numbered from 1 to 6
And
are
ma'am, next
participating.
question in
What is
4.
the probability that all even number horses complete the race at first, second, and third place?
In a horse race, 6 horses. Even
Is the answer half?
Did you see the videos of the practice solution?
No, ma'am, I don't know. Where will the video be at?
Okay, like in that there is a solution. Okay, in a horse race, 6 horses numbered from 1 to 6 are participating. What is the probability that even number of horses complete the races at first, second, and third place? Okay. Okay, fine. See, we have horses, okay, with numbered 1, 2, 3, 4, 5, and 6. We have 6 numbered horses, okay.
Yes.
Now, how many even numbers are there? 2, 4,
3.
and 6. We have 3 even numbers, okay. And we have to, like the condition is that all the even numbered horses should complete the race at first, second, and third. So at the first place, even numbers. So how many even numbers are there? 3. So
3.
from these, like there are three like 3 factorial ways in which I can have a like from these 3, the first place can be considered by the like
Yes, ma'am.
yeah, the first place would be in like any of 3 of them, that is 2, 4, and 6,
Yes.
Yes, ma'am.
Yes. So,
right?
ma'am, that will not be three
Sorry,
factorial,
Yes,
right?
ma'am.
three.
They're
It's
not
Twice
factorial.
six.
It's
so
3.
it's this is 3 because like it would be 3,
But
right?
next two
Then
positions,
2,
it makes
then
3
1.
factorial.
Okay, so this is 3 factorial only.
Can you
Yes,
say
ma'am.
like 3 out of 6? Sorry, not 3 out of 6.
So
Yeah, that would be
see,
wrong.
like there are 6 horses. So how many places are there? 1, 2, 3, 4, 5, 6. That means 6 prizes we have. This is the first place, second place, third place, fourth, fifth, and sixth, right? So the condition is that the first 3 places should be filled by the even number, right?
Yes, ma'am.
Yeah, ma'am.
Correct. Then the remaining would be filled by the odd numbers because only 3 are remaining. That is 1, 3, and 5. So
Yes, again 3
these
factorial.
again. So this would be 3 factorial. This is 3 factorial. This is 3 factorial, right? So, and what will be the total probability? This is the favorable cases,
Factorial.
right? This is the favorable cases. So if we need the total, like what would be the total case? The total probability, it would be 6 factorial.
6 factorial.
Right? So the probability that the even numbered are filled in the first, second, and third place would be equal to
36
factorial
by
3,
17.
factorial
2, 3
3 upon
factorial upon
6
6
factorial.
factorial.
Got it?
Yes,
Yes,
ma'am.
ma'am.
Okay. This was the only question that you had doubt?
If it was only for the
Ma'am, for calculating this, we'll have a scientific calculator feature in exam. For calculating the value, will we have that?
What?
For calculating the value of factorial, will we have direct in calculator?
I don't think so. You would be provided. It would be a basic calculator only. So you have to just open it and solve it.
Yeah. Can someone just put a reference to which question number was this? From which set?
This was this was a practice assignment 7.5 first question.
Practice assignment week 7?
Yeah,
Okay.
practice assignment 7.1 first question.
Okay. Thank you.
Okay.
If it is
Ma'am, in 7.6 activity, question number 4, I have doubt.
7.6.
just a
Question
minute,
number
in this
4.
question, I have a doubt.
Yeah, which question?
In the same question, if it was only the first 3 positions with even numbers, then the probability will be 3 factorial divided by 6 factorial, right?
Only for the?
No, we should arrange odd numbers also, so it will be multiplied.
Yeah, we have to like for the rest of the cases.
If we are only considering the even numbers as the first 3 positions, then if we are finding out the probability, then it will be 3 factorial divided by 6 factorial, right?
If like you're considering only the even numbers.
Yes. 2, 4, 6 only. So if we are finding out the probability of even numbers to be in the first 3 positions, then it will be like.
But you still have to fill the rest of the position, right? I mean, the question, even though it is given like you have to fill the horses in the first 3 position, you still have to fill all the position. That would be like essentially your one event, isn't it?
Yeah, or else it will become 3-digit number.
Yeah.
Correct.
Because there are 6 positions, there are 6 horses, so you have to fill it. So you have just made a like there are that is we have made a condition that the first 3 should be filled with the even and the rest would be filled by the other horses. That's the point. So it's basically that this is being calculated that the first 3 positions are being filled by the even numbered horses. Fine?
Fine.
Okay. So activity 7.6. Somebody had doubt?
Yes, for question number 4.
The probability. What is the probability of drawing? And then consequently, okay, so basically, if we say that we have to calculate the probability of K intersection A's, right? This is the thing that we have to calculate,
Yes.
right?
Ma'am, here what is S?
A's is the number with which is like we denote it as one number card. Okay. So this
In
is one
Hindi,
number
you call
card.
it as Ikka.
Ikka. हाँ. ठीक है.
Okay.
So
And
probability
there's one
of
question,
K
it is given as with replacement.
with replacement. So like if I am drawing from the 52 cards, if I'm drawing out one card, which is of king, okay, then I'm putting that one card again in that, okay. So basically, like in the second round, I'm having total 52 cards again. So from that 52 cards, we are again taking out one more card. Right?
Okay.
That is the meaning of with replacement. So if it's being replaced, that means they are both independent only, right? Probability of K into probability of A.
Yeah.
Yes.
Correct?
Yes,
So
ma'am.
probability of K would be like
4 by
what is
50.
4
4
by
by
52.
52.
and probability of A's would be
Same 4 by
4 by
50.
52.
4 by 52.
yeah,
Intersection 0.
intersection is 0. So this would be equal to Like the answer would be
1 by 169.
1 by 169.
Yeah. Now clear, ma'am.
Yeah. Okay. So shall we proceed like week 7? Shall we proceed to week 8 then?
Yes,
Uh,
ma'am.
Ma'am, I have a quick question. It's a very basic question, and I might
Okay.
have confused myself on it.
Okay.
When do you add the probabilities and when do you multiply the probabilities?
When they're disjoint, then we add the probabilities. And when they are like when we have disjoint, okay, then probability of A in union B would be the addition. Okay. When we have independency, then probability of A intersection B would be probability of A into probability of B. Right?
Okay, got it.
Got it?
Ma'am,
Okay.
can you explain that independent?
Yeah, I will explain it. Like it's in this week 8 only. So let's go by one by
Okay.
one topic.
I just wanted to
I have
confirm
a
one thing,
doubt.
ma'am.
Okay.
Ma'am, the syllabus for the qualifier exam is week 5 to week 8, but why other subjects they didn't announce the syllabus?
Which like maths and other
Yes, ma'am.
subjects.
Maths, English, and CT, they didn't announce the syllabus. For statistics, we got a clear email that the syllabus is from week 5 to week 8. But for the
Okay.
other subjects, we didn't get the syllabus, ma'am.
Oh, I don't know. Maybe you can mail them.
Is the graded assignment of stats? No, not graded assignment. The mock test of stat is graded. I think
Mock.
it's. I think
Like
it's graded.
bonus
Yeah,
mark.
yeah,
No, we'll get bonus
graded.
from.
Divya, he is asking something, you are answering something. Sorry for that. He
No,
is asking
no,
about the.
I am asking my question.
So for other courses, the syllabus would be week 1 to week 8 only. This is
Okay,
something which they change in this term only. That the syllabus of statistics is week 5 to week 8. Otherwise, it is week 1 to week 8.
so just to confirm, only statistics is week 5 to week 8, and all other subjects are week 1 to week 8.
Yes, most probably.
Okay. But statistics for sure is week 5 to week 8, no, ma'am?
Yes, it is for sure.
Okay,
I got mail for maths too. That syllabus is
Yes.
week 5 to week 8.
And he's in the maths one, I think.
Okay, I didn't get the mail then. Okay.
Maths and stats are from week 5 to 8. And the rest of the subjects are from week 1 to 8, I think.
Okay, all right. I didn't attend that class.
So,
Thank you so much.
so ma'am, which question I'm asking? That the mock test released today will be graded? Because in my
No, no,
portal is
no.
showing graded.
I too saw that it is graded.
And tomorrow is the deadline. They released today.
Divya, it's been already released.
It is.
Once it came
It
here,
should. It is
it's been
not
released.
graded. I don't think so. It is graded.
It's
Stat
graded.
1,
Yes, ma'am, it
stat
is
1
not
mock is not
graded.
graded.
It is not graded.
But it has time for it.
But what they say is normally when you finish the mock, normally you also get bonus or something in the end, at the end of the course. That's it. Mock is also considered for the bonus mark. So if you don't attend the mock, then I think there may be some. If you submit the mock, then you get some benefit out of for that also, even though it's not graded.
No.
Go through the grading.
No.
Go through.
Not only submitting this. You have to score. You have to score above 45%.
Fine. I think this is not the podium for discussing. Can we continue with that?
Yeah. Let's continue.
No,
So,
those things are required, no? It will help in the academic purpose.
okay, just we will discuss this thing in the last. Okay, let's complete it because I
Ma'am,
think
I have a doubt.
yeah.
Yeah, practice assignment 7.2, number 5.
Seven point two.
Number 5.
The event of A occurring and B not agree for two events can be represented as. Yeah, what's the doubt in that?
What is the probability that students selected at random has participated in both in singing and acting?
Sorry, your, I think 7.2 practice assignment 7.2.
Yes, ma'am.
Okay. What is the probability that the students in yes. Students have participated in this review and this review. You're not getting the answer?
No, ma'am, please do the question. I don't.
Okay, just can we do one thing? Just let me complete this week 8, then I will proceed with this week 7. Okay? Yeah.
Okay.
Okay. Just let me complete it. Okay, so in week 8, we would be like learning about conditional probability, multiplication rule, independent event, law of total probability, and Bayes. So these are some of the topics that you have to learn. Okay, that you have to remember. So the first topic is conditional probability. Okay, everyone remember the relative frequency table, right? The owning of a smartphone, right? We had
Yes, ma'am.
right?
Yes,
So
ma'am.
we had this, no, this was the table, right? Somewhat. This was the gender that this is female, this is male. So let's say this is 10, 14, 34, 42. So this was the total, that is 24, 76, 44, 56, and total was 100. Okay. Now I'm dividing each of these by the total frequency, right? So I'm dividing 10 by 100, 34 by 100. This is 14 by 100, 42 by 100. Similarly, I'm dividing these as well. Okay. So, so this would be like, so if I make another table, no, 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 yes. So this would be 0.1, 0.14, 0.34, 0.42, right? 0.44, 0.56, 0.24, and 0.76. Okay. So, so there are some of the values. These are the marginal. These are the probabilities. Fine. These are all the probabilities.
Excuse me, ma'am.
Yeah.
Conditional probability means what's the
Yeah, I'm
definition?
coming to that. I'm coming to that point. Okay.
Okay.
So in this table, we have 4 marginal probabilities,
Yes, ma'am.
right?
Yes,
So
ma'am.
probability of female, it would be 0.1 plus
And what
0.34.
is marginal probability?
Marginal probability means like we have two genders, right? These are the two genders, female and male. We have like two cases of owning a smartphone, no and yes, right? So these are like different categories. So we have, like, if I have to calculate the marginal probabilities or the probabilities of each categories, then we call it as a marginal probability. Okay.
Okay, ma'am.
Okay. Or you can say for the single attribute, like this is a single attribute, this is a single attribute, right? So if I have to calculate the probability of a single attribute, that would be called as a marginal probabilities. Okay. So what is the marginal probability of female? It would be 0.1 plus 0.34. This is the row of female, right? So I would be calculating this total.
Yes, ma'am.
Correct. Similarly, the marginal probability of male would be equal to
0.14 plus 0.42.
0.14 plus 0.42, right? This would be 0.56. So this is the marginal probability of male. Similarly, I can calculate the marginal probabilities of not owning a smartphone and owning a smartphone, correct? It would be 0.24 and 0.76, fine?
Yes, ma'am.
Yes, ma'am.
Okay. Now, what is a conditional probabilities? Okay. So, what do you mean by that? What do you mean by conditional probability? Like for case, if I'm consider, okay, see,
Sir,
if I'm considering among the female buyers, okay, among the female buyers, what
Yes,
is the
someone's
chance,
mic is on. Mute yourself.
Shivam? Yeah. So the thing is, I'm asking that among the female buyers, okay, what is the chance that someone owns a phone? Got it?
0.34.
0.34.
0.34.
So I am considering the conditional would be
0.34 by 0.
yeah. So it would be like the thing is among the female buyers, okay? What is conditional probability? That we have to calculate the probability given some conditions. So I have been given a condition that it is from the female, okay? And I have to calculate what? The female buyers who are owning a smartphone, right?
Ma'am, is it 0.34 by 0.44?
So it would be 0.34 by 0.4. Correct?
Ekdam.
Similarly, if my
Correct.
question is like among the female buyers who are not owning a smartphone, so it would be among the female buyers not
0.1 by
owning 0.1 by
0.44.
0.44, right? So this is the conditional probabilities. Okay. So what is a conditional probability? We are finding out the probabilities when when one condition is given. Okay, and it is denoted as like if I'm having two events A and B. Okay, so the probability of A given B, okay, this is a sign of given. Okay, it is not divide or something, it is given. So the probability A given B would be equal to probability of A intersection B upon probability of B. So this is the formula of conditional distribution. Got it? So if I go with this formula, so if I like in place of A, it is like in place of A, it is yes, and in place of B, it is female. So A intersection B, that is female, and it is yes, it would be 0.34.
Yes, ma'am.
Correct? And the probability of event B, that is probability of female, it is 0.44.
Yes, ma'am.
Correct? Probability of B, that is probability of F. F, that is this one, marginal distribution. So it is 0.44 only. So we see that this thing and this thing are same.
Yeah, ma'am.
Everybody got it?
Yes, ma'am.
Okay.
Ma'am,
Like
here, what is A, ma'am?
A, I'm denoting it as the person who is having a smartphone. Okay. And B is denoting the buyer is a female.
Okay, ma'am. Thank you.
Okay. Yeah. So let me take another example. Okay. So if I'm having an event, like my sample space is S like 1, 2, 3, 5, 6, 7. Okay. And one event A is like 1, 2, 3, and 4. And my B event is 3, 4, 5, 6, and 7. Okay. Now I have to find out the probability of A given B, right? So it would be probability of A intersection B divided by probability of B, right?
Yes, ma'am.
Correct. So A intersection B would be
2.
3 and 4.
3
2
and
by
4,
5.
right? So it would be 3 and 4, that is 2.
2 by 5.
Okay.
2 by 5.
2. Yeah, the probability of A intersection B would be 2 by 5 and probability of 1. So it would be 2 by 5 only, right? A intersection B divided by the probability of B,
Yes, ma'am.
right?
Ma'am.
Yes, ma'am.
Hello.
Yes.
And why this property holds true for probability? I mean, what's the mechanism behind this whole thing which we are doing? We are just taking intersections and dividing it with the probability of
See,
B. And
yeah. So if I draw it as a Venn diagram, okay. So we are having two events, A, and we are having the second event B. Okay. So A is like 1, 2, 3, 4, 5, 6, 7. So this event is B, this event is A, right? And 3, 4 are A intersection B only, the common thing.
yes, ma'am.
So this is the conditional probability of A condition B.
That represents if B had happened, A will also happen.
No, this states that what is the probability of A given that B has happened?
Okay. Yeah. So in the this set format, if we go, then this says that A and B both have happened. So this won't be a biased situation because in the mathematical set sequence, it could be A happened and then B happened, kind of.
I'm not getting your point.
And this is set Venn diagram. I mean the sets
Hmm.
we studied in maths.
Yeah.
And in that one we have studied that this intersection point is the place where the both domains value exist, and there was no condition that in which B will be first to happen and then A will happen. It could be the reverse also. So this set comprehension doesn't restrict the events happening condition, I think.
See, it's just a question. If I've been asked that you have to find out the probability of A given B, I would be using this formula. If I've been asked the probability of B given A, it would be another formula, right? So this would be probability of B intersection A upon probability of A. What will be the answer? It would be 2 by 4 only.
Yeah.
Here you are taking the number of elements in intersection and number of elements in B, right? For finding out the probability.
Yeah, so B intersection A is like common between them, right? So in common between them are two elements, correct? So it would be 2 by 7 from the total sample space. It would be 2 by 7, right? And probability of A would be what? Probability of A is 1, 2, 3, 4. That is these four elements. So 4 out of 7. So it would be 2 by 4 only.
Ma'am, this indicates
Yeah.
a kind of dependence between A and B, right? So the implication or the significance of this is it kind of indicates a dependency between the two events, isn't it?
They are dependency. Yeah, you can say that they are.
It is the occurrence of one event from another event which is already occurred, right?
Yeah.
B is the event already occurred. From that, we are selecting some events which is conditional, right?
A. Yeah, correct. Yeah. Okay. Is this fine? Can we proceed further?
Yes,
Number doubt.
But ma'am, sometimes I have seen E slash F or A slash B. Is this means that E given F?
Sorry?
Sometimes I have seen that you have draw a line that exact perpendicular line, but it will be slightly 45-degree angle. If I got the line.
It would be conditional only. So like it would be perpendicular only, like that only.
In case of conditional, it should be perpendicular.
Yeah, if there is a line between two events, it would be conditional only. Sometimes it is like writing mistake, so it would be slanting or something. Just remember it as a conditional only. Okay, sometimes it is like printing mistake or something.
Sometimes it's looking like the slash between either A or either B, looking like that. But
No, it's a conditional,
oh.
not a slash.
Excuse me, ma'am.
Yeah.
Ma'am, in the previous question, aren't we writing the number of elements in the A intersection B? We're not writing exactly the probabilities of the intersection.
We are writing the probability.
But ma'am, we have just mentioned the number of elements that are common between these two sets, that is 2. And the number of elements that are in set B in the
Because the 7 get cancelled.
got it, ma'am. Actually means that means that we got both the union of the sets and then the total number of that sets is 7. Okay, got it.
Okay, so can we proceed further? Now
Yes,
comes the
ma'am.
multiplication rule. Okay, what is multiplication rule? So, so we had a conditional, what was the conditional formula? It was like if there are two events, E and F, that it would be probability of E intersection F divided by probability of F, right? So my multiplication rule would be probability of E intersection F would be equal to probability of F into probability of E given F. Okay, so it's like multiplication rule, it states that the occurrence of both event A and both events E and F would be equal to the probability that F has occurred multiplied by the conditional probability of E given F. Okay, this is the multiplication rule. Okay, this formula. Okay, so let me take an example. So I am having in a class there are 40 students. Okay, among these 40 students there are 23 males and there are 17 females. Okay, and from these we are selecting two students at random. Okay, without replacement. Okay, we are not replacing it, it's without replacement. So we have to find out the probability that the first student is female and the second student is a male. Is the question clear?
Yes, ma'am.
Okay, so that means we have to find out the probability that the first student is, like I'm considering female as F and male as this one. Okay, so I would be considering F intersection M.
Yes.
The first position should be female, and the second student should be male. Okay, that is F intersection M. So this would be equal to probability of F into probability of M given F. That means, like, first of all, I have selected female student for the first, like I have selected first student as a female. Then given that I've selected one female student, from given that situation, I have to select one male student for the second position. Correct?
Ma'am, it should be F given M, right?
No.
Yes, ma'am, in the previous formula also, we can see that P of E given that F. So it is P of F. What we thought is in the denominator, what is the last? So it will come there.
Yeah, it's the thing that is in the denominator. It should be here only. See, the condition, just take the condition now. There are total 40 students. Okay, from that there are 23 males and 17 females, and from these we have to take out two students, and the condition is that it is without replacement. We are not replacing it. Right? So if I'm taking one student out from the 40 students, I have to select the second student from the remaining 39 students. Correct? That is the case of without replacement. Okay. Now the condition is that the first student should be the male and the second student should be male. The first should be female and the second should be male. Right? So I have to find out the probability F intersection M. Correct?
Yes, ma'am.
Yes, ma'am.
So according to the multiplication rule, F intersection M is probability of F, that is the event that I'm selecting the first student as female. Now the second, what will be the condition? Probability of M given F. That means this condition is already given. I've selected the one student that is female, right? Earlier only. So given this condition, I have to select the male student, the second student, which is male. Getting my point?
Ma'am, I have
Yes,
a doubt,
ma'am.
ma'am. Is it F intersection M equals to M intersection F?
Yeah, this is fine.
Okay.
Then this F M M in this one we will be finding first the intersection between M and F, and that should be 0, I think.
Why you are finding out intersection between them? 0.
We will be finding out this na female, given that female, and then we will be finding the males. So in this one we'll be calculating by finding the intersection and then dividing it by female probability of getting female. So the intersection would be 0 now.
Oh, you are going according to the formula.
Yeah.
Probability of intersection.
No, but here it is not asking common. It is asking first student male, female, then
Yeah,
male.
we are not like here. This is it is a situation only that the situation is that probability of F is like this is a condition. Like I have chosen the first student as female. Then after that, I am choosing the male student. So what is that probability? So see, probability of choosing a female would be from the 17 I
17
have
by
to choose,
40.
correct? Then probability that I have chosen female already, right? So like one student is
23 by
already chosen.
39.
So total 39 students are there. In that we have 23 male and 16 female, right? This is the
Yes,
condition,
ma'am.
right? Now I have to choose male, that is 23 male from the 39 students, correct?
Yes, ma'am.
Is it fine?
Yes, ma'am.
This example?
Yes, ma'am.
Yes, ma'am.
And this is the probability of M, that straight line, and then F na.
Yeah, probability of M given F.
Yeah. So
Okay.
the formula, it was the intersection finding such thing na. So we didn't it here.
Yeah, but here we are just taking the condition, like uh, probability of M given. So if you just use probability of M given F, the formula, it would be probability of M. Like see, from this formula only we are just predicting this value, right?
Yes, ma'am.
Yeah, so this is the multiplication rule only. If you have to find out the intersection, we would be using this formula. And this would be the some conditions. Like we have used, according to the conditions, we have used this value, right? In this, we won't be using the formula here.
Okay, the multiplication rule will be using here.
Yeah. Okay.
Okay,
Okay.
ma'am.
So is multiplication
I
rule
mean,
clear?
question if it is given with replacement, then it would be probability of F into probability of male.
Yeah, that would be a different case. Okay, that would be like if it's with replacement, that
You
means
will
they're
get
independent.
denominator 40 in second.
No, they're independent. That means they're independent, right? Like the first,
Yes,
like
ma'am.
selecting one student from the first case, like from the 40 students. Then after that, we are replacing that person. So in total, we have again 40 students, right? So these cases are independent. So it would be probability of M into probability of F only. That is a different case with replacement. Okay, we'll come to
Okay.
that. Okay, so yeah. So in this multiplication rule, we have two events, right? So if I'm having n events, then probability of E1 intersection E2 till En would be equal to probability of E1, probability of E2 given E1 into probability of E3 given E2 intersection E1 like this. It goes on. So probability of even given even intersection En minus 1. This is the formula. So if I'm having three events, let's say E1 intersection E2 intersection E3. So if I have to find out this probability, okay, so this will be equal to probability of E1 into probability of E2 given E1 into probability of E3 given E2 intersection E1. Is this fine?
Yes,
We
ma'am.
didn't understand this formula, ma'am.
This is just a formula. See, if I have to, like, if there are three events, like earlier we had two events, right? Probability of E1 intersection E2, right? So this was equal to probability of E1 into probability of E2 given E1, right? Now I have three conditions, E1, E2, E3. So if I have to find out this E1 into like E1, E2, E3, then it would be probability of E1 into E2 given E1. That means this thing has already happened. Then we would be finding out the event 2. Similarly, these E2 and E1 has already happened. Then according to this, we would be finding out the condition for E3. Correct?
Yeah. Okay, ma'am.
Okay.
I have
See,
understood.
let's take an example. Okay. Suppose there are three people. Okay. And we have to like there are let's say there are
I
14
have
kids.
request in the same previous question that I choose one female and other male. Could you actually do the same thing? The three event with the same problem where we choose two female or two consecutive male and then a female or vice versa from the 40 number that you mentioned above. Continuing the same example.
Continue the same example.
Yeah, the same example where we picked the first the female and then a male, right? What is the profit? That's what we found out there.
Yeah.
And if in this case, if you where you are talking about three events, it be something that like where we the condition should be that without replacement, consecutive two females and then the third one be a male. Will it be
So it
a
would be,
suitable example for that?
yeah, so it would be like probability of F. Then the second, like let's consider the probability that the second should be male. Then I'm considering that it again it should be female given that M intersection at the third event has already like the second event has already happened. Given this condition, I have to calculate the third event. Okay, like I'm giving you a simple example. Let's like do another example. Okay, like I am having 14 kids. Out of that, there are 6 girls. Okay, and we have like you can say 8 boys. Okay, now I have to like from these I have to take 3 kids randomly. Okay, so I have to calculate that what is the probability that all are girls. I have to calculate this probability. Okay, this is without replacement only. Okay, fine. So that means the probability of like there are 3 kids, right? So there are 3 events, E1, E2, and E3. Correct? That the first kid should be girl, the second should be girl, and the third should be girl. Fine. So I have to find out probability of E1 intersection E2 intersection E3. Correct? Is it
Yes,
fine?
ma'am.
Okay.
Yes, ma'am. Yes.
So this would be equal to probability of E1 into probability of E2 given E1 into probability of E3 given E2 intersection E1, right?
Yes,
So
ma'am.
what is probability of E1? That means the first kid that I'm selecting, it should be a girl. So what is the probability of choosing a girl? It would be
5 by 14.
6 by 40. Okay. Now the condition is that I have selected the first one as girl. Okay. So in total, like the first kid is already selected. So we have in total 13 kids now. And from that, we have how many girls? 5 girls and 8 boys. Correct?
Yes, ma'am.
So what will be the probability now of selecting the second kid? That should be a girl.
5 by 13.
5
5
by
by
13.
13.
Then the third. Now this
4
even
by
intersection
12.
even, that means this
4 by
condition
4 by
12.
12.
4 by 12. So this would be the answer. I'm not calculating further. So this would be the answer. Now you got it how to solve this question like that.
Yes, ma'am.
Yes, ma'am. Ma'am, actually, I have a small doubt in the formula, ma'am.
Yeah.
P of E1 intersection E2. Will you go up, ma'am? Yeah. Yes, ma'am. Here, you said E1 intersection E2 equals to E2 intersection E1, right, ma'am? When I ask you, ma'am, E1 intersection E2 is equals to E2 intersection E1, you said yes, right, ma'am?
Oh, yeah, if you have done. Okay, then.
So, how can we consider if it is E2 intersection E1, P of E2 intersection E1, then the formula will be same on RHS, ma'am?
See, you would be going according to the solution only. Okay, so my condition was like see, according to the question you would be going. So am I writing E1 intersection E2 intersection E3? Okay, so my first I would be selecting the first student, right? I won't be selecting the second student first, correct? So
Yes,
that's why
ma'am.
I'm going one by one. So E1 into E2 given E1 into E3 given E2 intersection E1.
Yeah.
That
Okay,
yeah,
ma'am.
so you have to go according to the question only.
Okay, ma'am. Thank you.
I have doubt in the third part of the formula where you are talking
Right.
probability of E3 given E2 intersection E1. I
Yeah.
think yes, I with that part because I understand the first two parts. I'm not
Yeah,
getting this.
the third part is that I have like these two events are already happened.
Okay.
Okay, this is the given condition that E2 and E1 has already happened. Okay, now I have to select the third student given that I have selected two students here.
Oh, oh,
Okay, so that's why it is 4 by 12.
So here we are not calculating this E1, E2 given E1 as like applying the formula and all.
No,
We are just
no, no.
according to the condition we are choosing, right?
One
Sorry to
more
go back.
silly doubt.
Ma'am,
May I
how it's
continue?
coming 6 by 14, 5 by 13, and 4 by 12, ma'am? It's quite confusing.
So see, the probability of selecting one kid from the like one girl from the 14 kids would be 6 by 14. Okay. Then after that, I have selected one kid. Okay. Now it is with
We have to subtract from the 14. 14 minus 1. Then we have to pick 5 more kid.
not 5 more kids. We have to select one more, like one kid from the 5 girls. See, one from the 6 girls, we have taken out one girl. So remaining there are how many girls? 5 girls. And there are 8 boys. So in total, we have 13 kids. You're getting my point?
No, I am not.
See, we have in total how many? See, there are 6 girls and 8 boys. So how many total kids we have?
In the first condition or the second condition?
First condition, I'm asking.
14 kids total.
14 kids. So I'm asking you to take like select one student from like select one girl from these 14 kids. So you would be selecting from this 6 girls, you would be selecting one girl, right? So the probability would be 6 by 14.
Yeah.
Correct?
It
Now
could.
similarly that see one girl is already out. So in total we have 5 remaining girls
Yes.
and 8 is there. Boys are there. 8 boys are there. Correct? So in total we have 13 kids in total. Now
Yeah.
correct? So now selecting one girl from these 5 would be 5 by 13. This condition, according to this condition.
We are choosing just girls.
Yeah, we are choosing only girls.
And after that 4 by 12. Okay, now got it.
Got it?
Then it will be 12. 4 girls will be left and 8 boys will be left. So we have to just choose the girls. But when we're
Yeah.
choosing 3 kids, then
See, I have a condition that all the 3 kids are girls only. That's why we are calculating this.
Okay.
Fine. Now let's jump into the next topic, shall we?
Ma'am, so
Ma'am?
excuse me, ma'am, one doubt I have regarding this topic.
Yeah.
So just because it is written as without any replacement, we are reducing numbers one by one. So if it is written like with replacement, the numbers will be same, right? We'll be
Yeah, the
multiplying the number
sum.
with the same
Yeah.
number, three times, right?
Yes.
For the previous question, ma'am, isn't it same as choosing three girls? There is 6C3 by the total number of
Yeah,
combinations.
it's
14.
same.
Same, right? Okay.
Correct.
Oh, yeah.
Okay, with regard to the that we have been discussing, when we talk about replacement, especially when it comes for boys and girls, I am picking, let's say the previous question, we are picking girl, and if there is a condition of the probability of replacement there, it should be mandatory again when it means replacement means only female or any kind of, it's boy or girl. If there is a replacement, I'm just for the my
See,
clarification.
with replacement
When we
means
talk about
that, yeah, with replacement, if you're selecting one kid, okay, and that one kid is a girl, okay, that girl you have taken out. So you would be replacing it, means that girl, like she would be put again into that line.
because
So
I'm
that is
thinking in
with,
terms of number of students, just for my
yeah, the number of,
that I want to clarify.
yeah, if it's with replacement, then the number of kids would be same only.
Yeah.
Ma'am, so with the replacement, it will be independent.
Yeah, it would be independent only. Because the number of kids are like, it's not depending on the see, if I'm taking out one kid from the 14 kids, then in the other it's with replacement. So from that total again 14, I'm taking out one kid, so it is being independent of the first event, right? Like it is, my second outcome is not depending upon the first outcome.
So
Getting my
second
point?
also will be 6 by 14. And third also.
Yeah. Okay.
Ma'am, I have a very silly doubt. Pardon my fundamentals. In this probability sense, we multiply all the probabilities. And what's that mechanism that really extracts the probability that we really want? I mean, by multiplying the probabilities of all these events, how do we get, I mean, any logic, any sense behind this all we are doing? I mean, just the multiplication that we are doing is all. This quite strikes me while using these formulas.
Why we are using this formula, you are asking that?
The mechanism of multiplication that we are doing with the probability, what it really makes logic sense that we can kind of infer from this.
It's just finding out the probabilities only with some conditions involved in.
Why do we don't do addition and why only
Because
multiplication?
see, this if you have done week 5 and 6, we when we use addition and multiplication, you would be knowing that. If I'm having two events and I have to if I have to calculate the probability of A and B, then I would be multiplying it, right? If I have to calculate, there are two events, N1 and N2, and I have to calculate the probability of N1 or N2, of happening of N1 or N2, I would be adding it, right?
Okay.
Yeah. So if I'm having like two conditions, like it is A and B, then I would be multiplying it. If I'm condition is like A or B, right? So I would be adding it.
Adding. And when A
Okay.
and B, then multiplying.
Yeah.
Okay, ma'am. Thank you.
Okay, fine. Shall we proceed further?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay, fine. You're having any sessions after it?
So how much time you will
I'm
take?
having maths too, ma'am.
Okay, so let me try to complete it. Okay. So, okay. Then the next topic is independent event. Okay. So what do you mean by independent event? It is that, like, we know that probability of E intersection F is equal to probability of F into probability of E given F, right? And I have been like So my independent event says that if there are two events E and F and they are independent, then probability of E intersection F would be equal to probability of E into probability of F. Okay.
Yes, ma'am.
This is the formula of independency.
Yes, ma'am.
Okay, so if it's so we can say that two events are independent when the intersection of both the events is equal to the product of their individual probabilities. Then we say that the two events are independent. Okay.
Yes, ma'am.
Okay, this is the case. So if I say like if I say that like for example, if I'm having probability of A equals to 0.4 and probability of B is equals to 0.3, then and A and B are independent. So what is the probability of A intersection B?
0.4 into 0.3, 0.12.
Yeah, it would be 0.4 into 0.3, which is 0.12. Okay, so this is the case. They are independent. That's why it would be equal to probability of A into probability of B. Okay. Now,
Yes, ma'am.
we have some properties in that. If I'm having two events, okay, A and B, and both are independent, fine. So tell me if A and complement of B, if they are independent also. Will they be independent?
Yes.
No. Yes, ma'am.
Yes, ma'am, because
Yes, they
the
would be.
complement is universal set minus B.
Yeah, it would be independent. So A and B complement would also be independent. A complement and B complement, A complement and B, right? So they would be independent.
No,
They will also be independent.
ma'am, how
Right?
can be A complement and B complement be independent?
See, I will like do one thing and you can see other. Okay, like the time is not there. So you want the proof of this thing? Okay, so let's see. There are two events A and B. Fine. This is A and this is B, and they are independent. Okay. So let me say that like event A can be expressed as A intersection B union A intersection B complement. What is A intersection B? This one. And A intersection B complement is this one. This whole will consider as an event A,
Yes,
right?
ma'am.
Okay. Now these two events are mutually exclusive. So it can be written as, so see, this is the probability of A would be equal to probability of A intersection B union probability of A intersection B complement. And they are mutually exclusive. So it would be equal to probability of A intersection B plus probability of A intersection B complement.
Yes, ma'am.
Okay. Now I'm saying that A and B are independent. So this can be written as probability of A into probability of B. Correct?
Yes, ma'am.
Right? Now I'm taking this side. So it would be probability of A minus probability of A into probability of B, which is equals to probability of A intersection B complement. Okay. So I'm taking probability of A common. So it would be 1 minus probability of B equals to probability of A intersection B complement. So this would be equal to probability of A into
The
probability of B
probability of B
complement.
complement.
Right? So this is the condition of independency. So the intersection of two events is equal to the product of their individual probabilities. That means A and B complement are independent. You got this?
Yes, ma'am.
Everyone?
Can you please little slow down and go again with the step 3? And
Okay.
it was little
See.
Yes,
fast.
ma'am, I do have a doubt in step 3. From step 2 to step 3.
Okay, from here, right?
Yes, ma'am.
See,
Yes,
the
ma'am.
probability of A, like My A is considered as A intersection B union A intersection B complement. This thing is clear,
Yeah.
right? I'm just adding P in like both like right hand side and left hand side. So probability of A is equals to probability of A intersection B union probability of A intersection B complement. Fine.
Yes, ma'am.
Correct. Now, this is a mutually exclusive events. Okay, that means like they are mutually exclusive. Like means what do you mean by mutually exclusive? That the intersection they are disjoint events. Fine.
Yes, ma'am.
बट मैम
Okay.
अगर हम देखें ए इंटरसेक्शन बी कॉम्प्लीमेंट कैसे डिसजॉइंट इवन हो सकता है क्योंकि इनका इंटरसेक्शन प्रेजेंट है ना यूनिवर्सल सेट से अगर बी को
No,
हटा
no.
दे
What?
अगर यूनिवर्सल अगर सैंपल सेट से हम अगर बी को सब्ट्रैक्ट कर ले तो उसका तो ए के साथ इंटरसेक्शन निकल के आएगा तो कैसे हम बोल सकते हैं कि ए इंटरसेक्शन बी कॉम्प्लीमेंट इज डिसजॉइंट और म्यूचुअली एक्सक्लूसिव इवेंट्स
Ma'am, will you tell the disjoint
I am
meaning?
saying that A intersection B and A intersection B complement are mutually like mutually exclusive events. I'm not saying A and B. I'm saying A intersection B and A intersection B complement. This part and this part are mutually exclusive only, right? There is no common point there.
these one are mutually exclusive
Yeah, that's what I'm saying. So A intersection B union A intersection B complement. So these both are mutually exclusive.
Yes, ma'am, as they
Yes,
don't
yes,
have
ma'am.
any
And they are
common point.
mutually
Yeah.
exclusive.
Now I can write. So you know that from the axiom 3. So probability of union of something, some event is equal to summation of probability of EI. So I can write it as probability of A intersection B plus probability of A intersection B complement.
Yes, ma'am.
Yes,
Correct.
ma'am.
Now I said that A and B are independent. So I can write it as probability of A into probability of B. Correct. Now I'm taking this side opposite to the equal side. So it would be probability of A minus probability of A into B.
Yes, ma'am.
Correct. Now I'm taking out probability of A common. So it would be 1 minus probability of B.
Yes, ma'am.
Yes, ma'am.
Correct. Now this 1 minus probability of B is B complement.
Yes, ma'am.
Now you
Got
got
it.
this?
Yes, ma'am. Got it.
Got it?
Yes,
Ma'am,
ma'am.
is it independent and disjoint sets are same?
No. Independency is different and disjoints are different. Independency is that the probability of A intersection B is probability of A into probability of B. And in disjoint, we have that the like you can say that the intersection between them is 0. These are
Okay.
two different things. Okay. Now, next topic is law of total probability. Is this thing clear? Can we proceed
Yes,
further?
ma'am.
Okay. Now comes the law of total probability. So what is law of total probabilities? It is written as like if I have to if I have to calculate the probability of an event A, some event A. Okay, there are two events A and B. Okay, so if I calculate the outcome of an event A, it would be equal to the probability that A, you can say that probability of A in intersection B plus probability of A intersection B complement. This was the thing. I
Yes,
can write
ma'am.
it as probability of A like that. Now, this is like A intersection B. These are not like disjoint or something. Okay, so I can write it as probability of B into probability of A given B plus
yeah
probability of B complement into probability of A given B
a b
complement.
complement
So this is the law of total probability. So what it states that Like it states that the outcome of an event like A or B or something, it is either in both A and B, or both in like in A but not in B. I can state it like that. That is law of total probability.
Yes, ma'am, got this.
Got it?
मैम
Everyone?
ये तो बेस थ्योरम को यूज करके है ना?
हाँ, the denominator. If I have to calculate the probability of one event, the total probability, then I would be using this formula when B occurs, when both A and B occurs, or when A occur but not B occurs. Fine?
Yes, ma'am.
Yes, ma'am.
Okay. Now, comes the base rule.
Can you give one example, ma'am? Can you solve one example for the above one?
Yeah, we can solve it.
Yes, ma'am.
Okay, let me just tell you the base rule. Then we will have one question in which base rule and that thing we will be solving. Okay.
Ma'am,
Okay, sure, ma'am.
ma'am, have you taken any session tomorrow?
No.
The calendar showing that.
I don't remember if there is any sessions tomorrow.
If you can take, then
Re-attempt quiz one.
Ma'am, tomorrow is the session of solving mock test.
Okay. So just let me complete this. Okay. So, okay. Now, like here, I am calculating the probability of some event. Now I have to calculate the probability of some like B given A. Okay. Now we are interested in conditional probability. Okay. Conditional probability of event B given that A has happened. So it would be equal to probability of B intersection A upon probability of A, right? This is the thing. Now, probability of B intersection A would be equal to probability of B into probability of A given A upon probability of A. That is this one, equation 1. So I would be writing this. So this is the base rule. Got it?
Yes, ma'am.
Okay. So
Ma'am, how did you write probability of B intersection A equals to probability of B into probability of A given that B?
We had a formula, right? B intersection
Ma'am,
A
can't
is...
it be?
Yeah.
Can't it be probability of A into probability of B given that A?
They are not independent. They are not independent. That's why we are using this formula. Okay. Okay. Let's solve one question. Okay.
Yes, ma'am.
Yes, ma'am.
Okay. Just last question. So there is a company in which there are 3 companies. Okay. A, B, and C, and it produces some like products with A produces 30% effective. Okay. B produces 40% effective. C produces with 30% of defective. Okay. Now, and choosing a company, from these 3 company is equally likely outcome. Okay. You know what is equally likely outcome?
All of them have same probability
Yes,
of
ma'am.
occurring.
Yeah, with same probabilities. Okay. So it would be like choosing the company A would be 1 by 3, B would be 1 by 3, and C would be 1 by 3, right? Then I have to find out the probability that the product chosen is defective. Okay. That means I'm considering the product is defective as probability of E. That like it is an event E. So I have to calculate probability E, correct?
Yes, ma'am.
Yes, ma'am.
So what will be my formula? That is probability that I have chosen company A, and by choosing company A, it is
Probability
defective,
of
right?
defective.
Plus, similarly, I have chosen B company, then probability of
Probability
E
of defective
given
given
B,
it is B.
yeah,
Taken from
then
B.
C, E given C. Is this formula okay?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now let's put the values here. So probability of choose A, that is probability of choosing A company would be 1 by 3.
1 by 3.
Into E upon A, that is like we have chosen A company and there is defective. It would be 30%, that is 0.3.
Yes, ma'am.
Correct?
3 volting.
Okay. Similarly, 1 by 3 into
0.4.
0.4.
Plus 1 by 3
1 by
into
3 into 0.3.
0.3.
So it would be equal to
0.1 into 4 by 3, or 0.1 plus 4 by 3 plus 0.1.
it would be 1 by 3. Okay. So
Ma'am.
this is the probability that the chosen product is defective. Is this formula clear? Is this example clear to everyone?
Yes,
Yes,
ma'am.
Okay.
Yes, ma'am.
Now I have to, if my question is, I have to
मैम
like, yeah,
ई गिवन है कैसे 0.3 आ रहा है?
E given A कैसे 0.3 आ रहा है?
हम्म
See, it is given that the company A produces 30% of defective items. This is the sentence. That means if I'm choosing A, so what will be my defective items? It would be 0. What is the probability? It would be 0.3 only. What do you mean by
ओ
this
अच्छा,
kind?
ए में
Yeah.
ए में ए का 30% डिफेक्टिव है.
हाँ
अच्छा
हाँ ठीक है.
ओ अच्छा, लैंग्वेज क्लियर नहीं था पहले.
Okay.
ओके
अभी ठीक है.
हाँ अभी फिलहाल ठीक.
Is this the example for the law of total probability, ma'am?
Yeah, this is the example of law of total probability. Now, if
Just
I
the adding up is the law of total probability. Am I right, ma'am?
correct. Now, like
Okay,
if
ma'am. Thank you.
like if I have to calculate the probability of like what is the probability uh, that it is probability that it is
Probability of
given that it is defective.
probability
Chosen
of A given that it is defective.
probability of given that it is defective. You have to choose that it is defective, but the company that it is from A only. So what it would be? Probability of A intersection E
Intersection
upon probability of E. Correct?
Yes,
So this
ma'am.
will be probability of
Probability of
what
E
will be
into
the probability of
probability.
A intersection E? It would be
Probability
probability
of
of A
E into
E by A
probability of E.
upon probability of E. Correct?
Yes, ma'am.
So just putting this formula, this value, it would be 0.1 upon 1 by 3 would be 0.3. Got it? So this way we can use the Bayes rule. This is the law of total probability.
Small doubt. What's the difference between P of A given F and P of F given A? I mean, how we can identify from statement, ma'am?
Yes, ma'am, I too have a same doubt.
Yes. What is the doubt? P of?
Actually, P of A given E. What's the difference between P of A given E and P of E given A? I mean, not from the value, from the statements. Like
This thing.
Yes,
yes,
ma'am.
ma'am.
In the
That's the thing.
formula, P of A intersection E, numerator.
This one.
I mean,
Yes, ma'am.
no, I mean like how we can find that if some question is given, how we can find whether it is A given E or E given A. That's my question, ma'am.
That's that's up to you. Like what you are, like if I'm considering, see, according to the question, like probability of A would be 1 by 3, that it is choosing company A. Okay. And I'm
Yes, ma'am.
considering E as an event that the product is defective. Okay. Now, according to like the question, it is given that A produces 30% defective. That means when I choose A company, the number of defective items were 30, right? That means E given A only. I had chosen A, and what are the number of defectives? 0.3. Got it?
Again, ma'am. Sorry, ma'am.
Yes, ma'am.
You got it?
I have question. You mentioned, I mean,
Again,
in the,
ma'am.
can you
Sorry,
hear?
sorry.
Sorry.
Yeah, one by one.
Could I or Roshni, you want
Yeah,
to continue something?
Sridhar. Yeah, you ask.
No, you mentioned about that mobile phone thing. It's called Marshall probability or Pareto probability. I'm sorry for that. I didn't get to clear the name of that.
Which probability?
About in the I'm not talking about even on the top. I mean almost in the middle of the section. We are talking about that.
Marginal.
It's a marginal probability. Okay.
Yeah.
Because I couldn't hear properly.
Yeah,
Just a second.
marginal.
Thank you so much.
Okay. So somebody was asking something. Is this clear now?
It's clear, ma'am. Thank you, ma'am.
Sure. Okay. So this was the last topic, the Bayes rule.
Ma'am, that means according to the question, we need to change the formula, right, ma'am?
Yeah, according to the question.
Yeah. Okay, ma'am.
So there is 5 minutes. Okay. So let me just one more question. Okay. Let's do one more question. Is it fine?
Yes, ma'am. It's fine, ma'am.
Okay. So okay, I will read out the question. An insurance company believes that people can be divided into two classes, those who are prone to have accidents and those who are not. Okay, there are two types of those who are prone to accidents. Okay, and one who are not. Fine. Then the data indicate that an accident prone person will have an accident in a 1 year period with probability 0.1. Okay, so it is saying that an accident prone person will have an accident in 1 year, okay, with a probability 0.1.
Man, the
Fine?
person can be injury prone, but not accident prone. It can be injury prone.
No, accident prone.
Continue.
It's just let's do the question. Time is going on. Okay. So there are two types of classes: prone to accident, not prone to accident. Now, from the accident prone person, like if the class is from accident prone, the person will have an accident would be 0.1, and the probability other than that would be 0.5. Okay. Now, suppose that that the probability of accident prone, okay, accident prone is 0.2. It is given that. Okay. So now what is the probability that, like, I have to find out if a new policy holder has an accident in the first year, what is the probability that he or she is accident prone? Okay. She is having accident in the first year. So I have to say, like, what is the probability that he or she is from the accident prone class? Everybody got my question?
Yes, ma'am.
Yes,
Sure.
ma'am.
If he is an accident in the first year, and what is the
No, ma'am.
probability that this
Please,
accident
once
prone?
again.
Once again, okay. See, there are two classes: prone to accident and non-prone to accidents. Okay. Okay, prone to have they have accidents and they have not. Okay, so the thing is, the data indicate that an accident prone person will have an accident in that 1 year. It is the probability is given as 0.1. Okay, that means he is from an accident prone class, and it is like that person is actually having an accident. The probability is given as 0.1. You got it? Okay. Similarly, the probability for all others, that means the person who like they are not from the accident prone and they are not having any accident, it is 0.5. 0.05.
Okay.
Okay. Now it is given that the probability 0.2 is that a new policy holder is accident prone. Okay. Like the person is from an accident prone. Okay. So that is 0.2.
Okay.
Okay. So now the question is, if a new policy holder has an accident in the first year, okay, it is given that he has an accident, then what is the probability that he or she is accident prone?
0.1.
So what, like, so how you will solve this? So first of all, like I have to, let us consider, like I'm considering.
Condition here is the person is, what is the person is the accident prone.
Yeah, if I'm considering F as an event in which, like, he is from the accident prone. Okay, he's from accident prone. Okay, and I'm considering I'm having an event E, which is he will have an accident. Okay, these are the two events. Now I have been given that the probability, what is probability of F, that is the accident prone, which is 0.2. This was the case.
Ma'am, I
Yes,
have a
ma'am.
doubt, ma'am. What is the difference between accident prone and accident?
Accident prone is like he's
There is the possibility of accident.
prone to have an accident. Like he had the possibility to have an accident. He had like actually he had an accident.
Ma'am,
That's a
here you
difference.
have given 0.1 is also the accident prone.
See, that's the thing. See, I'm coming to that point. Okay. So here it is given the probability that it is an accident prone. It is 0.2. I'm just saying only accident prone.
That is for the new insurance join.
Insurance, yeah, new policy holder. Okay. Now, and probability that he is not from the accident prone, it would be 1 minus 0.2, which is 0.8.
Yes.
Complement.
Yes,
Correct?
ma'am.
Now, what this states says, that is probability that
Probability of E given F.
given F. That means he is from the accident prone and actually he had an accident. This is equal to 0.1. Now you got it?
Yes, ma'am.
Okay. So now you got it how I wrote this E given F?
Yes,
Yes.
ma'am.
Similarly, so if I have to like, what is probability of E given F complement? It would be from this, that is that he is not
1
from the
minus
accident prone, but he actually had an accident. So it would be 1 minus 0.1 only, which would be
0.9.
this is given as 0, not 0.1, not this one. This is 0.05. It is given here. This is the probability that he is from the accident prone, but he is not he is not from the accident prone, but he is having an accident, which is 0.05.
Yes, ma'am.
Okay. So this way you can like know what the values that we have been given. Is it fine? Just see the lecture of ma'am, like in 7 point, the last lecture. You would be,
Yes,
yeah, you
yes,
would
ma'am.
be having the
Continue,
same
continue.
example. So just go through that. You would be able to do it like to how to indicate the values.
Is it recorded
Yes,
session?
ma'am.
Sorry.
Is it a live class or recorded session?
So what's the
This is
answer, ma'am?
recorded. Sorry,
And
what?
what's the answer, ma'am? What's the answer, ma'am?
It would be like you have to solve it. So I have to calculate probability of F given E, right? So it would be probability of F intersection probability E upon probability of E. First, I would be calculating the probability of E. What will be the probability of E? Probability of E would be
FQ1E means accident prone. Uh,
hmm,
what's the question, ma'am, actually?
question. It's in the lecture of
मैम एक्चुअली
the
क्वेश्चन आपका क्लियर नहीं हो पा रहा है इसलिए
okay.
स्टूडेंट को मुझे लगता है इसलिए
Uh, let me search for the question actually. It's
8 पॉइंट वीक 8 का 7.7 में ना मुझे
week
शायद
yeah 7.7.
मुझे भी याद नहीं है शायद देखना पड़ेगा
8 minute. Let me just share my screen so it would be helpful. Just 5 more minutes and
एक्सीडेंट प्रोन पेज
everyone
नंबर
able to
40
see?
पेज नंबर 45 में है
Yeah, everyone able to see my screen?
Yes,
या
ma'am.
या
Okay,
Yes,
so
ma'am.
see, just read the question. An insurance company believes that people can be divided into two classes. So there are two classes, prone to have accident and those who are not. Fine. Now the data indicate that an accident prone person will have an accident in 1 year period with a probability of 0.1. That was the same thing, right? That he is from an accident, that he is an accident prone person and he would be having an accident. The probability is given as 0.1. Right? And the probability for all others, that means that he is from the accident prone, that the person is accident prone, but he is not having any accident. That is 0.05. Fine.
Yes, ma'am.
So suppose
Ma'am,
that the
is the
Hmm?
answer 0.04?
I don't know, it would be. It is like 0. Just a second. 1/3. 0.3 something. So yeah, this was the question. Now the question is clear. Now is it fine?
Yes, ma'am, it's
Yes, ma'am,
fine.
it is fine.
Okay, ma'am, we will see after the session again of the question. क्योंकि मैम देखिए जब लेक्चर्स देखते हैं तो बहुत जल्दी जल्दी में देख लेते हैं, कभी कभार मिस हो जाता है कुछ चीजें.
But now you understood, like,
हम्म.
sure?
Yeah.
Okay, so any other, so this was the last topic.
Okay,
But we
ma'am,
have a
thank you
lot
so
of
much,
confusion.
ma'am.
Okay, so anybody having any other doubts?
So ma'am, for quiz 2 we have to study until independent variable.
Yeah,
Independent
base rule, base rule,
independent events. Base rule.
base rule. Okay. Just read the question carefully and solve it. Okay, just remember all the value, like all the formulas and all, and it would be easy. Just like give you 100%, right? Don't worry, it will be easy if you study.
When it comes to word problems, statistic word problems are just awesome. You boggle down your all formulas that you have dealt throughout.
Sorry.
I mean, the word problems are. My voice is clear.
Yeah.
The word problems, when it comes, all the formulas, all the things that we have mocked up, it all sits aside and the question wins. Sometimes the word problems make complications about the formulas which to use, how to imply, I mean, that thing.
Like it's simple that if it's asking, like it would be simple only. Like we are, like you have done all the activity graded assignments, right?
Yeah, graded and activity, yeah.
Activity you have done, right? So you would like, if you have done all that, then it would be easy for you to solve it. Just go through all the previous year questions, and you would be having the mock sessions as well, right?
Yes, ma'am, yes, ma'am.
Yeah. So just take a look into the previous year questions. If you're able to solve it or not, then you would be able to know that what type of questions we would like there would be, or are you able to solve it or not. That would be quite helpful. Just that in this type of the probability and all, you have to just carefully study the questions, what they are asking and what it is given. That's the main thing.
Yes, yes, ma'am.
Okay,
Ma'am,
just read
ma'am,
one by one sentences. That would be helpful.
ma'am, are you able to hear me?
Yeah.
Where can we get this access to the previous year questions or previous quiz questions?
I think that's available on the site or website or something.
Okay.
Yeah.
And,
Okay,
and this recording, can we
Ma'am,
access
one
the
second.
recording?
I wanted to ask a basic question.
Yeah. Yeah.
Excuse me, ma'am.
Yes.
So this may sound a bit basic, ma'am. Even though I know things so theoretically, not only for statistics, for other subjects too, I can I can able to understand things theoretically. I'm also able to solve theoretical problems, but when it comes to the applications, I'm struggling a lot. Even though having a lot of practice, it's really difficult for me. So, how can I encounter these kind of situations?
See, if you are practicing a lot, then that means you're just going through the same things that if I am given this, I would be using this formula. You're not using like you're not seeing that question as a practical thing. Like when I'm using this formula, you're not your mind is not concentrating on that thing. It's just yeah, you're using the formula. Just whenever you read a question or do a question or practice any questions, just read the question carefully. Why I'm using that formula, why I'm doing that, then it would be quite helpful.
Sometimes I used to get a sense of agitation that we only have 3 days left, so that's why I'm asking such kind of questions. So thank you so much for
Oh,
clearing this.
yeah. It's just that that what I'm saying. Like, just read the question carefully. Okay. Just remember all like whenever you start whenever you start an exam or something, whatever the formulas that you remember, whatever the things that you just write it in some. You would be having some rough sheets, right? It would be available, I think. So.
Yes, ma'am.
Yeah. So in that, just write like before like starting the question paper, just write all the formulas that you know, that you remember and everything. Okay. Then when you start that, then read the questions carefully and whatever you know. That would be like quite helpful for you. Because at the time of when you
Okay.
read a question or start any exam, like you get nervous and all, and you just forget everything. So before seeing that question paper and forgetting the things, just write it down. That would be helpful. Fine.
Okay, ma'am, I got it.
Yeah. Okay then. So
Ma'am, I have doubt in week 7 graded assignment question number 4.
yeah.
Okay, thank you so much.
Yeah.
Could I
Thank
take
you
leave
so
now?
much. Yeah, you can leave. If nobody's having any doubts, then you can leave.
Of course, I would like to stay because I'm sorry, I need to go for the other session also, which is also a revision for math. Sorry for that.
Yeah, you can go. Like if nobody is having any doubts, you can leave the meeting. If someone is having doubts, you can stay.
Thank you so much.
Yeah, for sure. Okay, all the best, everyone.
Thank you.
Okay. Yeah. Practice assignment. Can you tell me again?
Ma'am, week 7 graded assignment question 4.
Question. Mhm. Have you seen the graded assignment solution? There are, I think, PDF also.
I have not seen PDF solutions.
Yeah, just look into that. There
Okay,
are
ma'am.
solutions. Yeah. So then also, if you don't
Ma'am, there
find
are some previous question. Can I ask? In which
previous,
yes, ma'am. In which I find some difficulties.
okay. What is the question?
Ma'am, I'm sending it on the chat box.
Okay.
Ma'am, I have sent it.
Which question? Question number 81.
Yes, ma'am.
In a building with 5 floors.
Yes, ma'am.
you're having mock sessions, right? Any more sessions?
Yes, ma'am. Tomorrow there is also a session
Reattempt.
of mock quiz 2.
Quiz 2 mock, right? On Friday.
Yes, ma'am.
Okay, tomorrow. So actually, I need time to solve this. So
Okay, ma'am. Ma'am, can you explain next question?
an urn contains cards, right? This one.
Ma'am, even events having even is a event equal to number on the card greater than 150. Yes, ma'am, this one.
This one only, right? So now urn card contains cards. The number on the card is greater than 150 but less than or equal to 2. Okay, 18 is greater than or equal to 106 but less than 156. And the number on the card is greater than 60 but less than 100. Which are the following statements are true, even and into are indifferent? I'll tell you this question tomorrow. Okay.
Okay, ma'am.
I'll search about it.
Thank you. Thank you for the session.
Okay. Thank you, everyone. All the best, everyone.
Thank you. Thank you.
Thank you, ma'am.
Welcome. All the best, everyone. Now you can leave.